Topic 2-3, segments and distance. You can reference this with our textbook, Holt, Chapter 1, Section 2, on pages 13 through 19. The line segment, again, this is a definition, a part of a line consisting of two endpoints and all the points in between. To measure the length of a segment, you can use a number line to find the distance between the two endpoints, or you can use a formula. Again, notice that when you have a formula, the bars with the lines are like absolute value. So just remembering that anything inside of an absolute value, whether it's a negative or a positive, will always be positive. You're just talking about distance, not a number line. Okay, find the distance between -2 and 6 on a number line. Well, if you were to plot that on a number line where you've got a -2 over here and a 6 here and all the numbers in between, you take the -2, subtract it from a +6. So I emphasize that subtraction is adding the opposite. So if you think about it like that, if you're adding the opposite and you want the distance in between, you're going to have 2 numbers between here and 0 and 6 between 0 and 6, so that the total distance between here and here is 8. That total distance. Okay, let's do a few more examples. Example 2. Find PQ, QR, and PR on the number lines shown below. PQ would be from here to here. Well, you're at a -3.5, and that -3.5 is here. Subtract that from a -2. You've got subtraction. That's adding the opposite. Always think about a negative ends up making a big plus sign. -3.5 and a +2 becomes -1.5. Again, this is the absolute value of -1.5. Therefore, your answer, the distance between P and Q, is 1.5. All right, QR, Q to R. This value is a -2. This value is 2.5. Subtracting the 2 is adding the opposite. That was a +2.5, so now it becomes a negative. 2 negatives, -4.5 when you add them. Absolute value of -4.5 is +4.5. So QR is 4.5. PR, you've got from here all the way to this one. That was a -3.5, and subtract that from 2.5. Again, going back to your formula up here. -3.5 minus minus 2.5 is addition of the opposite. So 2 negatives become this become -6. The absolute value is +6. That's example 2. Moving on. When the segment is drawn on a coordinate plane, you can find its length by using the distance formula. The formula will always be given to you on a chart, so make sure you understand what these numbers mean. This is different than an exponent. These are called subscripts. As long as you keep your subscripts of this coordinate point together and this coordinate point together, it really makes no difference which one you start with, 1 or 2, but it is better to label. So for this example, I labeled the first coordinate x1 and y1, and the second coordinate points x2 and y2, just so they wouldn't get confused. And if I'm following the formula, all we're doing is filling in the values. -2 minus 2, notice I emphasized with color, becomes a positive. Make the +2 a negative. just reinforcing our integer rules. That added together the difference between the negative 1 minus a negative 1, that's tricky. Minus and a minus becomes positive, positive. That cancels out. You're at negative 1, you add 1, it becomes 0. We're still taking the square of the number, so it's important to remember that negative 4 squared is positive 16. 0 squared, of course, is just 0, so you're just dealing with the square root of 16, which is positive 4. And so I'm boxing the answer. Example 4. Label again underneath your coordinate points. Taking your x's, negative 2 minus 5 becomes plus a negative 5. Negative 3 minus a negative 2 minus a negative becomes plus a positive. Combining these terms gets you a negative, and so does this one. These become positive because negative 7 times negative 7 is positive 49. Negative 1 times negative 1 is positive 1. The square root of 50 we simplify. 25 times 2, 5 times 5. We've taken it down to its prime factors. When you get a pair, that can be completely factored outside of the radical. That's why this answer becomes 5 square roots of 2. A little bit of review of simplifying radicals. Example 5. This is when it's given to you in a graph. If the plotted points are in a graph, first name the point. This one we walk over 4 and up 5. This one's over 2 and down negative 3. Again, labeling them is a good idea. I made this A my x1 and y1, my B x2 and y2. Subtraction, 4 minus 2, this minus this, 5 minus a negative 3. We've done enough negative negatives to realize that ends up positive positive. Working it down, 2 squared is 4, 8 squared 64. Again, we're carrying the idea of square roots. The square root of 68, 2 times 34, 2 times 17. You have a pair of 2's, bring that up a little, a pair of 2's and 17. The pair of 2's completely factors outside of the radical, and this becomes 2 square roots of the 17. The 17 has to stay inside the radical. Again, review of simplifying radicals. Okay, last page. Examine the measures of PQ, QR, and PR, and this suggests the following postulate. The segment addition, if Q is between P and R, so that if you can draw a picture to put it between them, like there was in example 2. Go back and look at that. Let me bring this down. In this example, right here. The Q's in between P and R. So that means if I add P and Q plus the Q and the R, I'm going to get PR. You'll have the whole thing. Segment addition postulate. Okay, so looking at this, if you have an example, and we had to draw the number line again, if you have an example of A and C, AB is 4, BC is 5, then what would AC be? So they're looking for what's this whole segment if this partial segment is 4 and this partial segment is 5. Addition, segment addition postulate states that's just 4 plus 5 is 9. Next example, example 5. If AB is X, and so I've drawn, it's important to draw a picture. AB is X, BC is X plus 6, and AC is 24. So we're having to use segment addition postulate just to combine the X plus the X plus 6 is equal to the whole thing, 24. Combine like terms, addition, 24, subtract 6 on both sides, and also divide by 2. I've run out of room to show that. 18 divided by 2 is 9. AB is 9, so x was equal to 9. But be careful, BC, you have to substitute the 9 and add the 6 to get 15. So this x was equal to 9, so it's 9 plus the 6. We have to combine those two together. Don't forget an extra step. Sometimes they're not just asking for solving for an x value. Okay, last example, example 8. Find LM. I've highlighted LM because once we solve for x, we're not through. The NL is this value of 6x minus 5. LM is 2x plus 3. So what would be the, oh actually they gave this too. NM is 30. So segment addition postulate, adding all of these together. Combining like terms, this becomes 8x. Combine a negative 5 and a positive 3 is a negative 2. All of this set equal to 30. Continue to solve for x. You add 2 to both sides. This goes to 0, so you're left with just an 8x. Subtract 2 on this side is 32. Kind of run out of room, but to solve for x, you're going to divide by 2 on both sides. 32 divided by 8 is 4. 4 is not the answer. LM is what they're looking for. So you will substitute that 4 in the formula right here. 2 times 4 is 8, and 8 plus 3 is 11. These will be more like some of the examples in your worksheets. And that is topic 2-3.